Allora, tu sai, devo ancora fare fare. Capito, fa spilabili. Berapa ya? Trời ơi, bỏ đi không? Bỏ nó sẽ xin rồi. Nó phải đi thôi, cái là cái gì bán này đấy. Okay, meanwhile, for the rest, you have the question that you already given, right? Okay, so please give me the question. Ito po, soalan ko. So, which question today? Which question tonight? Question 3. I think I'm not your team, so I need to ask the question number 3, am I right? Okay, so please do question 3 while waiting for your friends. Bye. Ternyata one. Sorry, dengan ni, Miss Didi. Okay, I only have another six cup of tea. Tapi yang tak enam je yang bulat. Berapa dah dapat? Dah? Dah? Oh. Project Platas. Assalamualaikum warahmatullahi wabarakatuh. And a very good evening to everyone present in this call tonight. Alhamdulillah, in the permission and blessings of Allah Subhanahu wa Ta'ala. We are gathered here tonight for 10 design. We are gathering this knowledge and reading as inshallah. Begin our session with the remembrance of Allah Subhanahu wa Ta'ala. Let us recite our guiding office. Amin, amin, ya Rabbal Alamin. May Allah accept our dua and shower His mercy upon us all tonight. Without further ado, let us proceed to our main agenda for tonight. It is with great pleasure to invite our respected speaker, Madam Nur Sadia, Madam Nur Sadia Muhammad Ali, to deliver the topic. Please welcome. Thank you very much to MC. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, everyone. MashaAllah, full house, full hall tonight. So congratulations to all of you for getting time to attend the Chemzing in order for you to have our discussion here on topic 4, 5, and also 6. So I hope that you have the questions with you. Okay, but for those yang tak dapat, okay, so maybe you can snap picture here or you can jot down here the questions, right? Okay. So tonight, okay, we are going to cover question 3 and question number 4. So me myself will share okay, on question number 3, that is on topic atomic structure and periodic trends. Which means okay, you have discussed the first 2 questions which involve calculations part. And starting from this topic, we have a theoretical part. So which part that you prefer more? Calculation or the theoretical? That's theoretical. Okay. But still, okay, you have to master both now, regardless. In calculations or the theoretical part, you have to well first okay, on both parts. It to be excel in chemistry, inshallah. Alright. Okay, so shall we start? Okay, so refer to question number 3. In which part A questions, here we have full electron configuration for scandium. Okay, so the moment Alright. For electron configuration, then you have to alert that it can be in SPDF notation or in orbital diagram, isn't it? Alright. Okay, so another one is in orbital diagram. Okay, so the one that's provided to you is in SPDF notation. Okay, and question part one, okay, asking you to write set of quantum numbers. That is in terms of principal quantum number and angular momentum quantum number L, magnetic quantum number ML, and also the magnetic or spin quantum number. Okay? For the outer electrons of scandium. So what does it mean by the outer electrons? From the highest end value. So remember, when we talk about the electrons, here there are three types, namely inner electrons, valence electrons, and also outer electrons. So for outer electron, it should be very straightforward. That is referring to the highest end value. So for the scandium, the highest end goes to 4. N equals 4, right? So you should focus at here, the subshell 4s2. So what will be the four set of quantum numbers? And out of four quantum numbers, the most tricky one is the L. Agree? The angular momentum quantum number, that is L. So before you start to answer this question, okay, better for you to write down a reference. That is numbers to represent the angular momentum quantum number. That is 0, 1, 2, 3. That correspond to 0, that correspond to S orbital. 1 means P, 2 is P, and L equals P is F. Right? So then we can interpret what does it mean by subshell 4s squared here, based on the four set of quantum numbers. So N means 4. Okay, and then L, we are talking about S orbital, right? So L must be
Tak keluar lah madam. Dia freeze.
then proceed, yeah?
Alright.
Okay, then L is 0 and ML is also 0 because ML is said to be negative L to positive L including 0. So when L is 0, ML automatically 0. And the MS only two values. Now, that is the positive half or negative half. Okay, and take note we have two electrons resides in 4s orbital. Okay, therefore, you can have either positive half combination or we can have another option that is 4, 0, 0, and negative half. So any of the combination is correct to represent the set of quantum numbers for the 4s2 subshell, that is the outer electrons, right? So the key point here is L. So make sure you interpret L correctly. If you misinterpret the L, then ML will be wrong, isn't it? Because the ML will be depending on the L. Okay. So now let's move to part 2. Identify the block for scandium. So to identify the block, you have to refer to the last subshell. So what's the last subshell in the electron configuration of scandium? 3D1, right? Thus, the block for scandium is said to be D block. That is how you identify the block. We have how many blocks in the periodic table? There are 4 blocks. We have S block, group 1A to A, P block, group 3A until 8A, isn't it? And then D block, there is the transition elements, and F block, there is the inner transition elements, right? Okay, next, write the full electron configuration for scandium. So this is common question, right? Okay, another full electron configuration, but now for scandium 2 plus. So what does it mean by 2 plus? Yes, it is an ion. What does it mean by positive charge? Loose electron, isn't it? So lose 2 electrons. So now we have to remove 2 electrons from the scandium electronic configuration that is given earlier at here. So how do we remove the electron? From which subshell? From the outermost shell. That is from the highest end value. It is not from the last subshells, eh? So this is common mistake by students. They thought that the removal of electron is from the last subshells, from the 3D, which is incorrect. Eh? So the removal of electron should be from the outermost shell, or from the highest end value, right? That is from the 4s2. Did you agree on that? Okay. And how do we respond to the question? The question asks you to write. So be careful with the terms I here. If the instruction asks you to write, it means that if the question asks for SPDF notation. Okay, because it can be asked in another form, that is draw. Draw the full electronic configuration. So what does it mean? What is the expected answer? The orbital diagram, the platform with the electrons using arrow, isn't it? So you have to alert with the instruction. Okay, and so we have full electron configuration means you have to start from 1s. So you just follow the electronic configuration given, but you have to remove 2 electrons from the 2s, sorry, from the 4s2 subshells. So 2 electrons will be removed as here. Thus, we have 1s2, 2s2, 2p6, 3s2, 3p6, and 3d1. Because 4s2 has disappeared already since there's no electrons in it. We have removed the 2 electrons. Right? And when we talk about the electronic configurations, do you remember the 3 rules governing the electronic configurations in order to get the ground state, the most stable state of the electronics arrangement? What are the 3 rules? Aufbau's rule. Here we have Aufbau's rule. And then we have Pauli's exclusion principle. And the third goes to Hans rule. So what is the main point highlighted by them? Aufbau's, what is the main point highlighted? It is about the main point only. The elaboration you can develop by your own. It is about the energy level, isn't it? So it is about energy level. How about Pauli's exclusion principle? There are 2 points highlighted by Pauli's. What are they? Each subshell can be occupied by 2 electrons, or in simpler version, only 2 electrons per orbital, isn't it? Yeah? So 2 electrons per orbital. And another one more point? What else? How we say? Only 2 electrons per orbital and another one more? Quantum number. The electron should be in opposite spin, isn't it? Macam yang sedikit je. Tengok. In opposite spin, eh? How about Hans? Hans, see? The electrons should be singly arranged. Okay, for p orbitals, for d orbitals, which consists of more than one individual orbitals, the electrons should be singly arranged before they are packed with opposite spin. Okay, that is according to the Paulis. So Hans said that the electron should be singly arranged. Okay, that is Hans said. So when we arrange the electrons in order to achieve so-called ground state, all the three rules should be fulfilled by the electronic configuration. Right? But for this case, you are given the electronic configuration already, right? So you just need to refer to the electronic configuration as provided to you. Okay? So hopefully you still remember the arrangement of the orbitals according to the outbounds. Because that one would be the template, isn't it? So let's recall them. What will be the arrangement according to outbounds? 1s, right? So we start with 1s, followed by 2s, and then 2p with 3 individual orbitals, isn't it? And then 3s, 3p. So starts from here, we have the 4s arranged first, and this is according to the outbounds. So we have 4s, and then we have the 3d, which consists of 5 individual orbitals. So after 3d, only then we have the 4p. After 4s is 4p. After 4p, it's supposed to be 4d, right? But another adjustment happened where we have the 5s followed by 4d. And continue. So this is supposed to be the template for you to use in order to work with the arrangement of electrons, right? So now we move to part B. Okay, part B. In table 2, shows several elements with their proton number, respectively. We have element T, R, M, with respect to their proton number. So can we identify what is the elements given to us? Yes. Here you can refer to the periodic table actually. So do you have your periodic table with you? Discuss topic 4, of course. Now you have to have periodic table to refer to. Okay, so can you identify what is actually T? Bromine. R, calcium. And then M, chlorine, Cl. Is it? Okay. So now, what's the question? Ask for. Arrange the elements in increasing order of atomic size. So what are the main factors that influence size of an atom? There are two main factors, right? Which are size. Another one? The effective nuclear charge. That is Z, or sometimes pronounced as ZF. Right? So Z, right? So these are the two factors that influence size of atom. Right? Okay, and you should give the arrangement in increasing order. What does it mean? From smaller to larger size. So always interpret the questions correctly. Right? So increasing order means from smaller size to larger size. Okay, so that the arrangement is correct. Okay, so now let's do the analysis so that we can relate with the two factors in the principal quantum number n, size n, size n. Sorry, we are talking about atomic size, right? Semua orang buruk je. Kan, tak bertukar pun benda. N. It is supposed to be principal quantum number n. Kan? And second is self. Okay, so now let's look at analysis. Okay, for element T, bromine. So bromine comes from which period? So period 4. So n equals 4. And which group? Because group can reflect the Z value, isn't it? So the group for bromine is 7A. And then for R, element R, from which period? Also from period 4. But group 2A. The N followed by M, from which period? Period 3. And group number? The same as T, isn't it? 7T. So based on this analysis, by right, you can see already which atom has the smallest. Which atom has the smallest? Because based on the principal quantum number n, you can predict already. Because we have two different principal quantum numbers, n equals 3 and n equals 4. So obviously, n equals 3 will give you the smallest size of the atom. Therefore, the smallest size should be given by m. So the smallest is m, okay, followed by. So now between T and R, since both of them are from same period, that's period 4. But the difference between them is the group number that can reflect the effective nuclear charge, Z, in which T, the position of T is further right of the periodic table, isn't it? And causes the Z to increase. So what does it mean by Z increase? So this one has the higher Z. So what does it mean by Z increase? The net attraction between valence electrons and nucleus stronger. So the stronger the attraction, then the smaller the size. Right? So which one is smaller, T or R? So T is smaller. Okay, so T is smaller. Thus, the largest goes to R. So this is the correct arrangement. So now we develop the explanation point by point according to what we have analyzed just now. Okay, so we start with which one you want to start? M, no? Yeah. So M, the main factor is because of the principal quantum number n. So you can see that n has the smallest size due to what? Due to the lowest n or principal quantum number. Okay, lowest n or principal quantum number. The lowest principal quantum number. That is given by n equals 3. That is the first point. Okay, and how about P and R? So we can compare in terms of the Z, in which the next point to be developed is that measure now T and R are in the same period. They are in the same period. That is n equals 4. Isn't it? But okay, or you can come up with another point. However, pun boleh juga. Setuju. However, P is smaller than R because it has greater ZF. Okay. So what does it mean by greater ZF? Stronger. Okay, because it has greater ZF, it achieves stronger net attraction between valence electrons and nucleus. Okay, nucleus. Okay, there's size. Not it. Size is smaller is already mentioned earlier. Yeah, full stop. Okay, so now let's see what are the important points to be captured. So first is the arrangement. Okay, that is in increasing order. Okay, but sometimes students tend to get confused with the sign less or more. Okay. So if you are not sure to use the symbol less or more, what you can do is comma. Kan? Itu adalah comma. M, comma, T, comma, R. Macam motor kan, MTR. Okay, and then put arrow increasing. Increasing order. Alright? So if possible, try to avoid careless mistake lah, because you know the arrangement, but because of the incorrect symbol used, then it will affect your answer. Okay, next point, when you mention M has the smaller size because of the lowest principal quantum number. This is the first point for the explanation. Okay, in terms of principal quantum number. Okay, and the next point, if you mention that T has greater Z, that gives stronger net attraction. So this to capture the next point. Okay, for the explanation of T and R. Right? Okay, what do you know? Are you following? Yes? Okay. So next. Okay. Let's see the part B question that is on successive ionization energy. So the successive ionization energy. Huh? Okay. Guys, are you okay? Okay? Bunyi-bunyi bising tadi tu bunyi sel kertas kan? Sel belakang tu hopefully Zef masih higher. Right? Okay, very good. So thank you. Okay guys, so successive ionization energy, okay, the questions can appear in the form of table like this, okay, or in the form of plot. Isn't it? Have you seen the questions of the successive ionization energy using plot? Okay, you can see, okay, the increment is quite steady, and then suddenly there is a big sharp increase or drastic increase, isn't it? Okay. So the successive ionization energy is important, okay, to give you information on what? Valence electron. Okay, we are able to determine the number of valence electrons, okay, based on the shell transition, which happens due to the drastic increase in the delta. Isn't it? And based on the valence electrons, what information you can solve? Group number, very good. Okay, we can solve for the group number. And the question might ask you to come up with the valence electronic configuration. So you have to prepare a valence electronic configuration. Okay, so now let's see. Okay, you are given the data for successive ionization energy for four main group elements A, G, D, and E. On top of that, the successive ionization energy covers main group elements What is meant by main group elements? S and P block. S and P block only. Okay. So now let's see what is the question. Identify the group number for element E. So group number. So to determine group number, we have to solve for the valence electron. So E here. So now let's see the trend. To remove the first electron, it requires 1,100 kilojoule of energy. And to remove the second electron, 2,400. So we can say that the increment is almost double, isn't it? Okay, and to remove the third electrons, 4,600. So also double. Okay, and the next increment, so this one, kita kan? Double, this is also double. Okay, and to remove the fifth electron, it requires 38,000. So what increments applied here? From 6,002 to become 38,000. Wow, so it is almost 6 times, isn't it? 6 times 6 is 36, but now it's 38,000. So 6 point something here increment. So what does it mean? There is a big jump increase between IE4 and IE5, which indicates shell transition. Okay, ada peralihan petala from outermost shell to the inner shell, right? So be careful here. Make sure you interpret them correctly. Okay, in which the big jump increase happens between IE4 and IE5, which indicates the presence of 4 valence electrons. Always refer to lower number. Eh? So there are 4 valence electrons of element E. So what does it mean by 4 valence electrons? What is the group number? Group 14 or group 4E. Can we put the answer as group 4? Cannot. Because this one can be referring to 4B, isn't it? But for this case, it is the 4A. So please do not leave your answer as group 4. Be specific. 4B or 4D. Okay? Okay, next, element B. Element B. So now let's have a look on the trend for element B. So can you identify between which IEs there is so-called drastic increase though? Between which IEs? Right. 400 to become 4,000, and then 6,009, 9,005, 13,000. So is it between IE1 and IE2? So if they see we are not confident, because 13,000 is large number, what? So there are options for you to identify. It is either you subtract between IEs, 4,500 minus 409, or you convert them into ratio, divide. So either one lah, kan? So if you want to get ratio, then you have to divide 4,500 to the 490, or you can subtract them. Then you find out that the increment is almost tenfold, isn't it? 10 kali ganda ni. So obviously lah, okay, the big jump increase happened between IE1 and IE2, which means how many valence electrons? 1 valence electron. So D, it is the element from group 1A. Okay, and what's the question? D is from period 4. Right? And then identify the element and write the electronic configuration for D. So there are 2 instructions here. You have to identify and you have to write the electronic configuration, isn't it? Okay, so to identify, very straightforward, right? Macam itu. So what is the element? So for the period table, go to period 4 and group 1A. So it is potassium. Either you put K, symbol K, capital K, or spell it up as potassium. Okay? And how about the second instruction? Write the electronic configuration, isn't it? So write the electronic configuration. What does it expect to write? The instruction asks you to write. What is the expected answer? So it should be in SPDF notation. Okay? It does that for this case. There are two options for you. You can give SPDF notation full or SPDF notation condensed. Because there's no specific instruction asking you to give full electronic configuration, isn't it? So you can choose either one. So if they say you want to express in full, how many electrons belongs to potassium? 19, based on the proton number, right? So you have to arrange the 19 electrons, okay, according to the energy level. Okay, and you have, what is the first level? 1s2 followed by 2s2, 2p6, 3s2. So far we have 12 electrons, isn't it? And then 3p6, 4s1. So can you count? It is sufficient number? 19 altogether? Alright. Okay, all alternatively, can you provide in condense? Yes. So how do you calculate to condense electronic configuration? You have to refer to the noble gas that is in preceding period. And if potassium is from period 4, then you have to refer to the noble gas from period 3. So what is the noble gas from period 3? Argon. How many electrons? 18. Which means that the first 18 electrons here can be replaced with argon. And the remaining should be written as it is. That is 4s1. So either one, oh. So choose now which one that you prefer. Right? Okay. Okay, next. Okay, part 3. Okay, write the general. What does it mean by general? Valence electron configuration. Ah, we have to use the general principal quantum number that is n. Because we do not know what is the period number for the element A, isn't it? So usually when the instruction asks you about general valence electron configuration, so general means you have to use the term N. Okay? So now, how many valence electrons belongs to element A? Refer to A. So between which IEs there is so-called drastic increase. So do you agree that the drastic increase happens between IE4 and IE5? Okay, because 4,000 to 16,000. How much? The increment? Quadruple, isn't it? 4 times. Yeah? So element A has 4 valence electrons. So again, always choose the lower number. Right? Okay, so now, how did you arrange the 4 valence electrons belongs to E? Is it an S4? What? Uh, which rules? Which rules that, that is not fulfilled by the NS4? About Pauli's exclusion principle, isn't it? We see that only 2 electrons per orbital. And S orbital has only one individual. And S subshell has one individual orbitals only. So it cannot accommodate 4 electrons. Cannot. Can we have NP4? Yes, mashallah. So is this the correct balance electronic configuration for element A? No. Right. This is inconsistent to outbound. Outbound said that every subshells you have to start with S10. Okay, or sorry, this is outbound. Okay. Every shell they should have S followed by P, isn't it? So you must have an S followed by an P. And now how to arrange the four electrons? NS2 followed by NP2. So NP4 is incorrect. Cannot. Because the general valence electron configuration should start with NS followed by NP. Eh? So common mistake did by student NS4 now, NP4 now. So they are incorrect. Cannot. Right? Okay. So now, let's move to this question. Very famous question, isn't it? Huh? English. Another trend for you to arrange that is also related to size, that is increasing size for the following species. You have oxide, O2 minus, and the magnesium 2 plus, the magnesium ion, and nitride ion, N3 minus. Okay. So what is the possibilities for this question? What is the possible connection between them? Huh? Ion hilang? Neon, very good. What does it mean? Neon? Tak cukup. Mana? Oh, tengok dia salahkan soalan tak cuma maklumat. Masya Allah. Oh, dalam ni orang ada. Okay. So cancel neon from your question. Soalan you all yang salah. Okay, please cancel neon. Okay, but actually, there is a hint for you. That is supposed to be the hint. Yeah. Okay. So, guys, if they say you are given a series of ions, you remember? Always consider for the possibilities of isoelectronic series. What does it mean by isoelectronic? Same number of electrons or same electronic configuration, isn't it? Yeah? So if they say you are given a series of ions, always consider for the occurrence of the isoelectronics. Okay, in which we might have a species having same number of electrons or same electronic configuration. So now let's confirm. Okay, are they the isoelectronic? So how do we know? Recall the proton number now. Refer to the periodic table and find out what is the proton number for each of them. So O2 minus, what is the proton number? 8, isn't it? Okay, and then magnesium? Magnesium, 12, followed by nitride, and 3 minus 7, isn't it? Okay, so now, let's come out with the number of electrons possessed by them. Number of electrons. Oxygen 2 minus. What does it mean by 2 minus? Receive 2 electrons. So 8 plus 2. You give you 10 electrons. How about magnesium? Magnesium 2 plus. Lose 2 electrons. So 12 minus 2. 10. See? Yeah, almost. To confirm that they might be the isoelectronic end. And 3 minus. So receive 3 electrons. So 7 plus 3. That is 10. Confirm that they are the isoelectronic. Isn't it? So they are the isoelectronic series with which number gas? With neon. Isoelectronic with neon. Isn't it? Okay. So now, how do we arrange their size in increasing order? So again, increasing means from small to large or big, from smaller to bigger size. Right? So how do we identify the factor? Number of electrons is the same, isn't it? So by right, the number of shells also the same. But what's the difference between them? The Z value. Isn't it? The nuclear charge, the proton number here, A12, 7 that correspond to Z. The proton number. Okay? So guys, if you have isoelectronic series, they always refer to the nuclear charge that is Z proton number, which can relate to the ZF, the one that you used to work with, isn't it? ZF. That's the net attraction. Okay, in which you can see that the greater the Z, the greater the nuclear charge, then the greater the ZF, effective nuclear charge as well. So the greater the effective nuclear charge, then I can continue. The stronger the net attraction between valence electrons to the nucleus, thus the smaller the size. Isn't it? Okay, so now let's arrange. So small size should be given by large or small z. Kan? So smaller size should be given by larger z or zf. Isn't it? Okay, and larger size should be given by smaller z. Because smaller z means weaker net attraction, isn't it? The weaker the net attraction, then the larger the size. Okay, so let's arrange. In order to get the arrangement from smaller size to larger size, we have to arrange from higher Z to lower Z, or higher Z to lower Z value. So which one has the highest Z? Magnesium 12, isn't it? 12. So we have magnesium 2 plus is the smallest. What about? Okay. Increasing size. Smallest to the largest kan? You all betul kami dah lah. So the smallest should be given by Mg2 plus Ini. So Mg2 plus 12 proton number. Followed by O2 minus with 8 proton number. Okay, and the largest goes to N3 minus with 7. So see this friend? 12, 8, 7, sini. They correspond to the proton number. Okay, so now, how do we develop the explanation? Because the question asks you to explain here. So what is the main factor just now? Let's explain it again. The Z, isn't it? But before we work with the Z, how do we calculate the Z? It's based on the Z. Okay, in which we can say that. So for this time, it requires you to explain that, to compare. Because you have different species at here, right? Okay, so you can start the explanation by using first, first study you have to mention that all ions are iso electronic species with Ne, neon. Or maybe you can mention all ions have the same number of electrons or have same electronic configuration. They are equivalent. Same. Okay, and then the moment you have identified that these are the isoelectronic, then you can work with the factor of Z, proton number, that can be related to the Z, in which from magnesium 2 plus to N3 minus, what you can see? Z increases, isn't it? And Z decreases, sorry. Okay. Z decreases. So what does it mean? When Z increases, Z also decrease. Kan? Betul kan? Betul tak? Huh? So when Z decrease, what does it mean? Weaker net attraction. Isn't it? In weaker net attraction. Yang tu kita sabar nak pergi ke next question lah tu. Attraction between valence electrons and nucleus. Thus, smaller the size. Thus, smaller size. Bigger. Sorry. Dia juga yang ngantuk. Oh, you nak test with all tu. Okay, the bigger the size. Okay, so now let's see. What are the important points? Okay, what are the important points for us to capture? First is of course now the arrangement, yeah. And the arrangement. Okay, and then isoelectronic and dua je makan je. Apa yang tu? Okay. Okay. Hint, tips for you. If they say the mass allocated is 2, you have to provide at least 3 or more. Okay, always provide more. Yeah? But make sure all points are consistent lah. Yeah? Okay. Okay, next. Okay, the moment you have identified that they are isoelectronic, so the main factor is actually the Z, isn't it? That is given by the Z value lah. The Z, okay, Z increase and Z, okay, this one, mana dulu? Okay, so when Z increase, yeah, this one also part of previous point, right? So when Z decrease, Z also decrease. Yes.
And tu lebih banyak ni kan. Repulsion electron lagi tinggi kan.
How did you measure the repulsion? Because number of electrons for them is the same. Yeah, they have 10 electrons, isn't it? What does it mean by 10 electrons? If they say you work with the Bohr model, you have 2 followed by 8, isn't it? 1s2, 2s2, and 2p6. Betul tak? So how would you measure the repulsion? So how much electrons too? All of them having the 10 electrons, isn't it? So apa beza dia orang? What is the difference between them? Yes, the quantum number inside the nucleus. So that's why the main reason for these isoelectronics because of the nuclear charge. The quantum number inside the nucleus will determine how strong is the attraction between nucleus and the valence electrons. Okay? Okay, thank you. Very good questions. Okay. Common mistake. Okay, guys. Another common mistake made by student, okay, was to compare between the ions. And to say that, oh, N3 minus has stronger repulsion than O2 minus because N3 minus receive more electrons. Kan? Ya ke? Untuk repulsion, untuk yang macam tu biasanya we are comparing between same elements. For example, we compare between Astagfirullahaladzim. Madam kelas kat sini dia tanya pula kat situ je. Patut datanglah sini. Okay guys. For the response just now, okay, very good. Okay, thank you brothers. Okay. That one, you can use name. For example, nitrogen versus nitride, N3 minus. Okay. So, how did you compare between them in terms of size? Which one is smaller and which one is larger? Is it N atom or N3 minus ion? Which one is larger? Let's see. Which one is larger? And let's do the analysis. Let's analyze them. How many electrons nitrogen has? Proton number, they are the same, isn't it? They have the same proton number because they are the same element. So nitrogen 7, this one also 7, isn't it? What's the difference between them? Yes, the number of electrons. Nitrogen has? Masya Allah, 5 electrons. How many total? Total. They compare, try to compare total. Nitrogen, 7 proton means 7 electrons, isn't it? And then N3 minus 7 proton by 10 electrons. So the difference between them is in terms of the number of electrons. For this case, then you can relate with the electron repulsion. So N3 minus has extra electrons by 3 numbers. So that's why the electron repulsion and in N3 minus is stronger. Isn't it? The stronger the repulsion in the N3 minus, what happens to the electron cloud? The stronger the attraction and the stronger the repulsion between the electrons in the N3 minus, what will happen? The larger the electron cloud. That's why the larger the size. The one you can compare in terms of electron, but isoelectronic cannot. Huh? Okay guys, yang belakang dapat point? Angkat tangan untuk soalan ke? Yang kat belakang tu? Yang tu maksudnya apa? Tak ada soalan ke? Tak dengar ke? Tak nampak ke? Tak nampak? Tak faham? Yeah. Yang belakang. Kenapa? Permit ke Teams? Join eh? Dia orang yang confused comparison and ion dengan parent electronic function kan? Kita dengan parent. Kalau ya ini kisah dia iso elektronik. Nampak tak? Cuba tengok. Bisa pakai lah. Yes. And that also. But closer. It's quite much more than that. And so Mong cái đó em sẽ nói các cái pieces the common head to that as the new clear chart. As the new system and as the close up. So this one is not an ion. It must come an ion. Expand the size of the ion. When you think of plastic ion, what say there? So we do like the sun is okay, guys. Okay, guys. Okay, let's back to the discussion. Thank you very much. And for those who ask you questions, controversy sebenarnya asymptotic ya. Kan? Okay, so one of the questions just now raised by brothers is that for this sensory electronic, do we have to calculate the Z? Do we have to calculate the Z? How do you calculate the Z? Z minus F, isn't it? Okay, but that one is in terms of the calculation parts now. But usually, for this case, no need to calculate. Isn't it? Because the obvious reason can be seen at the Z. From Z, you can prorate or you can relate to the Z already. Okay, if they say it insist to do the calculation. So yang lain tak perlu tenang. Yang lain bertenang. If you manage to grab the concept that isoelectronic is mainly due to nuclear charge Z, then keep that content with you. Keep that point with you. But if they say you want to determine the Z, they say, madam, saya kena juga calculate Z. Only then I will be confident to develop the explanation, kan, for example. So how do you calculate the Z? Proton number, isn't it? For example, magnesium 2 plus. How do you calculate the Z for magnesium 2 plus? Z of proton, the Z is proton of magnesium, that is 12, isn't it? Minus S means what? Inner electrons for shielding effect, isn't it? So, how many inner electrons? Two. It is one S2 to S226, right? But according to Bohr, usually you can use Bohr so that you can see the differences between shells, isn't it? So, at the first shell, you have 2 electrons. At the second shells, you have 8 electrons, isn't it? So, inner is 12. So, 12 minus 2. That is positive 10. So, magnesium has positive 10 Z. Kan? Betul tak? Ya, betul. And the nitrogen? N3 minus. What is the Z? What is the proton number of nitrogen? 7, right? Okay, guys. Ada yang dah tipuan mimpi nampak dia tu. Okay, so guys, Z is said to be Z minus X, right? Okay, so now can we calculate for the Z of nitrate or nitrogen 3 minus? So what is the proton number of nitrogen? 7. What is the inner electrons? 2, because they have the same, isn't it? So mungkin lebih 8. Okay. So S should be given by the inner shell. That is 2. So 7 minus 2 is? Positive 5. So magnesium just now is positive 10. Same here. Okay. Yeah, then? Oxygen? What is that? 8 minus 2. That is positive 6. And F3 minus is positive 5. So, is it tally? Isn't it? Are they tally? The Z? Are the Z tally with the Z? Yes. As Z decreases, the Z also decreases. So, kenapa nak susah payah nak calculate sel tu? Kan? Banyak lagi soalan lain nak jawab ni. Relation kind of things involve calculations. Relation stoichiometry also calculation, isn't it? So for this case, you guys, so can we come with one agreement? If you have the isoelectronic series, work with Z, proton number. Okay, in terms of the arrangement, should be based on the Z. And when you want to explain, of course now you have to relate to the Z. So remember, when Z increase, Z also increase. So when Z increase means the net attraction between valence electrons and nucleus become stronger. The stronger the net attraction, then the smaller the size. Right? Okay, agree? Okay, guys, thank you. So hopefully, okay, when you have questions on isoelectronic, you are able to answer. You are able to give correct structure okay, in the explanation part. Okay, another controversial question. Agree? After. How did you explain this? Okay, let's read the question together. Oxygen has a lower first ionization energy than nitrogen. Explain briefly. Kan? So, ah, apa sama kau? Yang mana? Yang mana sama kau? Eh, so ini bukan dua markah, tiga markah. Please make correction. Okay, guys, please correct question F. Instead of 2 marks, change to 3 marks. 3 marks. Right? Okay, guys. What's the idea about first ionization energy? What is first ionization energy? It is about energy required to remove 1 mole of electron from 1 mole of gaseous atom to become 1 mole of gaseous ions. That is the cation. Okay? So to remove an electron, which is attracted to the nucleus, of course requires energy. So that energy must we have to overcome. Is it? Right? So generally, when we talk about the first ionization energy, the trend is increasing. Oxygen and nitrogen, they are the elements across the same period. Agree? You have nitrogen, oxygen, fluorine, for example, because this one is very related to the intermolecular bonds that we discussed afterwards, isn't it? Yeah? So nitrogen, group 5A, and then oxygen, group 6A. Yeah? So generally, across period, the first IE will be increasing. That is what is expected, increase. Group 1A, 2A, 3A, 4A, 5A, and etc. However, there is irregularities happens between certain elements. And or we regard them as small dip to happen. And the small dip happen between group 2A, 3A, isn't it? Me. Group 1 and group 1A, group 2A, and suddenly decrease. Right? So this is not the actual. Okay, and then increasing again, 4A, 5A, and another dip can be observed at here. Is it? So we can see irregularities happen in the first IE. And the irregularities, they will happen between group 2A and 3A. Another one combination is between group 5A and group 6A. Yes. Right? And oxygen is from group 5A. Sorry, nitrogen is from group 5A, whereas oxygen is from group 6A. So that's why we can have the irregularities. That's why we have a statement lower. Oxygen has lower first IE. So how do we explain the irregularities trend here? It is based on electronic configuration. Huh? You have to see what is the arrangement of the electrons of the nitrogen and oxygen so that you can evaluate what is the main reason, what makes oxygen to have lower IE, or what makes the group 3A here to have lower IE, for example, because of the small dip just now. Isn't it? Huh? So now let's work with the electronic configuration. For this question is very straightforward because the question asks oxygen has a lower first IE. So we can focus on the oxygen. Okay, basically, yeah. So what is the electronic configuration of oxygen? So oxygen has how many electrons? So 8, So we have 1s2, 2s2, and 2p4. Sorry. Okay, and if you want to compare with nitrogen, for example, so nitrogen we have 1 electron lesser or fewer, is it? That is 1s2, 2s2, and 2p3. So based on the statement, we can see that to remove an electron from oxygen is easier as compared to the removal of an electron of nitrogen. Agree? Okay. So now let's see why it is easier to remove an electron from the oxygen as compared to nitrogen. So according to the electronic configuration, which electron is to be removed? Ah, from the paired electrons in 2p. Is it? So when an electron is removed, okay, it is removed from a pair of electrons in 2p orbitals. So what makes electrons can be removed more easily? Because of the electron repulsion. Yeah. So that is the only electrons that resides in pairing, which experiencing the electron repulsion. So when there is electron to be removed, so it is easier to remove the electrons because of the electron repulsion enable. Okay, the process of removing the electron. So now how do we present in terms of point? Yeah. So yeah, it is about removing electron, right? So an electron, okay, is removed from okay, a pair of electron in 2p orbital. Okay, which experiencing electron repulsion. Okay, which experience the electron repulsion. Okay, so that's why okay, thus the easier to remove the electron. And what happens to the IE? The lower the IE. Okay, easier to remove the electron and lower IE required. Or less energy required. Betul juga. Sebab lower IE mentioned already kan in the statement. So, okay, we can put less energy required. Okay, and less energy required. Right? And there's another normal statement actually that is related to stability. Okay, in which when this electron is removed, what will happen? It produces half field of 2p orbitals that is more stable. So that's why easier to remove. Okay, a pair of one electron from the pair electrons in the 2p orbitals. First, because of the electron repulsion, and second, because the resulting species is more stable with half field of the 2p orbitals. Right? If you want to add on one more, resulting. And the resulting species or ions, the resulting ions, it has more stable, more stable, configuration, stable, configuration of half field, 2p orbital. Right? And how about the irregularities between group 2A and 3A? Another irregularities is between group 2A versus group 3A, isn't it? So again, the explanation they can be developed based on the electronic configuration. For example, group 2A. Let's say regardless now from which period. So we consider the balanced electronic configuration. So group 2A is NS2, isn't it? With 2 electrons. Whereas group 3A has NS2 followed by NP1. Okay, for example, boron. So for boron, let's say this is belongs to boron. So boron has 2S, right? Okay, 2S2 and 2P1. Isn't it? So which one has lower IE? This one? Before boron? Siapa dengan boron? Beryllium kan? Between beryllium and boron, which one has higher or which one has lower IE? Boron has lower IE, isn't it? A small bit too is because of the boron has lower IE one. Why? It means that boron can gives out an electron very easily. Agree? Why? So the electron that we want to remove belongs to these electrons. And to remove these electrons is easier. Why? What is the reason? Because the electron is to be removed from 2p orbital that is further from nucleus. 2s followed by 2p. So when the location is further from nucleus, the attraction is lesser or weaker. And that's why it is easier to remove the electron. So for this case, the point to be highlighted is easier to remove electron. Okay, easier to remove electron from 2p orbital that is further from nucleus. Further from nucleus. And that experiencing weaker attraction. Further from nucleus. Okay, that experiencing weaker attraction. That's why easier. That's why lower AIE involved. That's why there is the deeper. This is for boron, this is for beryllium, and this is for boron. You want to? Okay? Alright. So that is the atomic structure and predict trends. Guys, for predict trends, only two trends covered. They are the size and also ionization energy. Isn't it? And then for the atomic structure, okay, you have to alert with the atomic orbitals. How did you describe the atomic orbitals for our discussion? For this level, for this syllabus, how did you describe an atomic orbitals? Based on quantum numbers. What does it mean by atomic orbital? What is atomic orbital actually? Apa itu atomic orbital? It is the 3D region where probability of finding electron is the highest. Right? So why we highlighted the 3D regions? Because we want to introduce to you the atomic orbitals that is in spherical, s orbital, dumbbell, p orbitals, isn't it? The property, p orbitals, and the complex shape of the m orbital, isn't it? So to describe an atomic orbitals, here we use the quantum numbers n, l, nl, and also ns. Okay, and then for the electronic configuration, which is about the arrangement of electrons, isn't it? And the arrangement of electrons should be governed by the three rules that we have emphasized just now, which are the Paul's rule, Pauli's exclusion principle, and also the Hans rule. And last but not least, you have the Philip trend now here that covers the size and also the ionization energy, right? All right, so I think that's all for my part. Okay, I hand over the next discussion to regular my discuss report. Thank you very much.
Beda kena
Assalamualaikum. Assalamualaikum. Alhamdulillah. Masih bersemangat. Masih sedih? Yang ke atas tu kalau tak nampak boleh turun-turun. Ada lagi space kat kaki tangga ni pun boleh. Atas. Nampak ke? Nampak? Nampak Okay. Minum lagi 10 minit untuk you try question dulu boleh? Okay, cuba dulu. Itu kalau memang nak attach your cups, yes, kita lah. Attach Coba dulu ya.
Boleh, tapi kena
Okay, guys. So how so far? Dah sampai which question? The last one? Dah siap dah? Guys, sister, brothers. So how is it? Soalan tu apa dah? Last question. Ada siap? Alhamdulillah. Dan sampai nasi boleh kena tu tu. Semua ada yang volunteer nak datang depan. Yang sini jom. Okay, sebelum kita mula, okay, saya nak tanya lah. Okay, this is your last two topics in your chemistry one, which is chemical bonding and also intermolecular process and heat. Which part do you think that the most difficult for you to understand? Yang aku susah sangat nak buat. Hybridization. Lagi? IMF. Karangan. Tak ada karangan kat sini. Oh, explanation. Explanation which part? Which topic? IMF. Oh, IMF ni masalahnya. Okay, dengan hybridization. Okay, go. Jom kita tengok. Since you have a problem with hybridization and also IMF topic, okay, which is most of the IMF is about explanation. So, Madam akan more focus to that part, ya? Boleh? Boleh, ya? Okay, jom. Okay, number 4A, do you have a problem with this? Tak ada problem, ini skip. Senang je kalau yang sahih dia, tak ada problem, skip. Tak ada problem, skip. Tutorial 20 minit habis.
Okay, jom tengok kita. Well, let's have a look at the answer for this A. Okay, and you can check with your answer. Okay, so if let's say you were asked to show the formation of ionic bond, okay, make sure that even though it's not stated, use Lewis electron dot symbol, even though it's not stated. Okay, for example, in the question just mentioned that show the formation of ionic bonding in aluminum oxide. Then the way you show the formation of ionic bond must by using Lewis symbol. Okay, mesti gunakan Lewis symbol. Okay, so for this example, okay, for this question, okay, kita ada aluminium, okay, with how many dots? With how many dots? Three dots. Okay, one, two, three. Okay, atas sekali nampak ke? Yang atas sekali, cukup bawah tak? Nampak ya? Okay, good. Okay, and you have two aluminium. Okay, so mungkin apa, nak memanjang boleh, nak ke bawah boleh, nak ke atas boleh. No problem with that. Okay, so you have here aluminium, one, two, three. And then you have oxygen, three oxygen atom with how many dots? Berapa valence electron oxygen? Hafal ke? Hafal. Okay, you don't have to memorize. What you need to do is just equal to the predictable because predictable will be given. Yeah, during the exam. Okay, so with six dot, one, two, three, four, five, six. Okay, and then you have three oxygen atom. Okay, one, two, three, four, five, six, and another one, one, two, three, four, five, six. Okay, and to show the formation, you have to show the movement or the flow of the electrons. Yeah? So you have to show that this electron, okay, shift to this, okay, and this one, to this side, this oxygen atom, and this oxygen to here. Ah, we can up to that instead. Okay, and for this one, to this oxygen atom. Okay, you have to show the electron, yeah, the movement of the electron by using arrow. Arrow ni wajib. Tak ada arrow, no marks. Okay, and then the product will be produce Al3 plus and oxygen with 6 valence electron, 2 minus. Okay, is it the same as yours? Okay, good. Next. Okay, check the number of sigma and pi bond present in CO2. Sigma bond how many? 2. Pi bond how many? 2. How many non-pairs? 4. Okay, good. What is the geometry of the CO2? Molecular shape? Linear. What is the electron group arrangement? Electron group arrangement for CO2? Electron group arrangement for CO2. Nah, dengar tak kata electron group arrangement? Tengok textbook, tengok textbook. Textbook guna electron group arrangement kan? Textbook guna the word electron group arrangement. Okay, what we call electron group arrangement? Kan? Electron group arrangement kan? Okay, apa? You guna term apa? Oh, basic shape. Oh, basic shape. What is the basic shape for CO2? Okay. Oh, you got a basic shape. Okay, what is the type of hybridization for the carbon? Oh, dah bisa semua. Dah habis lah. Okay. Compound lain dah? Compound? Okay, if let's say you have H2O molecule. H2O, very simple. Hari-hari minum air. Hari-hari minum H2O. Okay, what is the shape? Molecular shape band. Okay, basic geometry. Electron group arrangement ataupun the basic geometry. Basic shape. Thank you. Okay, first. Now, berapa lepas kita tu? Okay lah, make sure dia tolak tepi dulu. Okay, jom kita tengok yang ni. Kita sambung yang ni yang ada. Kalau ada masa kita discuss lagi dulu ya. Okay, so now let's draw the orbital energy diagram to describe the hybridization process for the carbon CO2. Okay, normally for the hybridization, we apply for the central carbon. Normally. Okay, but note out that for the terminal atom with multiple bonds. Okay, terminal atom with multiple bonds. Okay, we can also determine the type of hybridizations for the terminal atoms. Yeah. Okay. And since you mentioned just now that the C or the carbon having the type of hybridization of sp, sp2. sp, okay. So what you have to do the hybridization process. If you are talking about hybridization process, you have to start with the ground state of the carbon atom. Okay, you are the carbon atom. You have here this is the energy actually. Okay, and then you have here the 2s orbital with 2 electrons. This is the ground state. Ground state. Okay, and at the p orbital, we have how many electrons for carbon? You have how many electrons for at 2p orbital? 2 electrons. Okay, so now the question here, how do we know that it's undergo excitation? Akan berlaku tak excitation, which is the electron from S aside to P. How do you know? Boleh tahu? Okay, the restructure for CO2 just now, ini kan? Okay, macam ni tahu. Because there is a certain compound that, okay, you can just keep the excitations. Am I right? Betul kan? Okay, so persoalannya di sini, how do we know that this one have to undergo excitation? Tapi sikit ke? Boleh ke tak? Tak boleh. Kenapa tak boleh? Dia punya ni kat sini. Kita tengok dekat carbon, you look at the carbon. If the carbon consists of 4 bonds. Ada 4 bonds. 1, 2, 3, 4. Meaning that the carbon atom have to protect itself with 4 single electrons. Carbon tu kena ada 4 single electron. Okay, so how can the carbon atom have 4 single electrons? By undergoing excitation. Okay, excitation means that the electron from lower energy level aside to higher energy level. So you ada kat sini kita panggil dia excited state. Okay, and then make sure that the energy level for the 2s masih sama. The energy level for 2p pun still the same. This is 1 electron tinggal sebab the other electron is assigned to 2p orbital. Okay, begini. Ada 3. Cuba kira ada 4 tak single electron? Ada 4 single electron, right? Okay, so then next it will hybridize. Okay, so how do we know that it's only S and 1p hybridized, not all the p? Ada yang tahu, ni ada semua ni. Banyak macam tahu ada satu dia dengan 1p je, bukan 2p, bukan 3p. How do you know? Sebab apa? Sigma bond. Sebab ada pi bond. Macam tu sebab ada pi bond. Okay, kalau medium, okay, sebab dia ada 2 group of electron. I'm talking about groups of electron compound. I'm talking about groups of the electron. Ada dua group kan? Ni one group, one triple bond with 3s. Kita anggap dia as one group of electron. So we have two group of electron. So your carbon have to prepare itself with two loops. Okay, yang ada two loops tu yang ada dua orbital adalah sp. Betul kan? Okay, jadi ini dua ni S dengan P, one P ni dia akan hybridize. Hybridize tu maksudnya dia mix. Okay, dia mix dan dia akan jadi apa? Dia akan jadi new orbital with the name of sp hybrid orbital. And what will be the energy level of this sp hybrid orbital? Kat mana energy level dia? Sama dengan S, sama dengan P? Tengah-tengah. Between these two. Okay, so here two electron with sp hybrid orbital, and you have another two electrons in 2p orbital, which is this electron we call it as unhybridized electron. Unhybridized electron. Ini electron yang hybridized. Okay, nama dia nama orbital dia sp orbitals, whereas this one we need in 2p. And the electron we call it as unhybridized electron, ya. Okay, so next. So apa next? Okay, but before that, this is your hybridized state. Okay, so the next one, you have to draw the orbital overlapping, am I right? Okay, orbital overlapping for carbon, since you know that this is sp, so sp means consists of how many loops? Two loops. Two loops. Okay, and make sure that you label. So, mungkin dia ada cantik sebab medal dulu masa SPM, tulisan medal fail. So, macam inilah ukur dia. So this is sp label, okay? This is sp orbitals, okay? And then your oxygen, okay? Your oxygen is your multiple bond, so means that you can also determine the type of hybridization, am I right? Okay, mana dia? Kita punya CO2 tadi. Ada CO2, okay? What is the type of hybridization for oxygen atom? sp2, sp2, 1, 2, 3 group of electron. So kalau 3 group of electron ni siap, kita guna hybrid orbital yang ada 3 loops, which is sp2, isn't it? Okay, what will you try with 3? Try dengan plana. Okay, good. Try dengan plana for oxygen. Oxygen. Okay, 1, 2, 3. Okay, label. This one is sp2, sp2, sp2. Jangan lupa label. And same goes for the other oxygen atom. It's also sp2, which is diagonal planar. Okay, this is your sp2, sp2, sp2. And the orbital overlapping, the area where the orbital overlap, make sure that you draw the two electron, a pair of electrons, and this orbital overlapping will form the sigma bond. Label. Okay, label. Okay, and dekat sini, the other two sp hybrid orbital for oxygen, you have lone pair. Ini lone pair. This is lone pair. This is another lone pair. This is another lone pair. Okay, and again, if you look at the Lewis structure of CO2, okay, dekat sini, then from this orbital overlapping, it's just explain the formation of carbon, oxygen, one bond. This is produce one bond. It explains the formation of this sigma. And also it explains the formation of this sigma bond. Okay, so how are you going to explain the formation of another bond between carbon and oxygen? Okay, nak guna apa? Okay, that one will be known as pi bond, which is using the number, the unhybridized, the unhybridized, just unhybridized, berapa unhybridized? Dua, okay, kita lupa p orbitals. Down there, okay, one, this is one p, which is two, two p orbitals with one electron. Okay, satu lagi. Satu lagi. Okay, so this one. Okay, this is another 2p orbital with one electron. So, okay, and your oxygening pun ada unhybridized electron. Okay, this is 2p electron. Okay, so the overlapping between these two will form one pi bond. Okay, and the overlapping between these two, this is another p orbital. Okay, don't place the same axis here because the p orbital and p orbital can only overlap, okay, between same axis. Okay, kalau sengit kanan lah, jangan satu sengit kanan satu sengit kiri. Ya, cutting je, then not. Okay, kalau tegak, dua kita tegak. Okay, so this is your 2p as well with one electron. Okay, and this is the overlapping. Okay, then explain another formation of this pi bond and also the other one from this pi. Okay. Okay, faham tak? Faham. Good. Okay, next. Okay, go. IMF. Wow, IMF. Okay, go. Two compounds have the same molecular mass are given below. Okay, explain why. Okay, explain why the boiling point of hexane is higher than 3,3-dimethylpentane. Okay. Macam nak explain ni? Ni kan ada questioning. Mesti dah tanya ni dalam soalan dalam exam. Mesti ada. Okay, so how do you explain? Can I explain? Okay. So the first thing, before you can answer this question, which is they ask you about the differences. Yeah? Why is it this one is higher than the other one? Means the difference. Okay. The first thing that you have to mention is the similarities between these two. Bagi tahu dulu apa dua-dua ni ada. Lepas tu baru tengok what is the difference. Faham tak? Okay. So for example, 3,3-dimethylpentane and hexane are non-polar compound. Betul? How do you know dia non-polar? Abang minum cakap. Sebab dia ada carbon dengan hydrogen je. Okay. Yeah. Hydrocarbon compound, okay, which is consists of carbon and hydrogen only, then that compound known as non-polar compound. So bila dia adalah non-polar compound, then the intermolecular forces that present in the molecule is only random dispersion forces. Okay, so both are non-polar, thus only LDF ataupun only exhibit LDF. Okay. Maksudnya both compound having same type of IMF. So why is it the boiling point different? Must be because of the strength of LDF different between these two compounds. Isn't it? Okay. What are the factors that determine the strength of LDF? Apa dia? Apa dia? Molecular shape and molar mass. Molar mass. Okay, so in this between these two compounds, which factors will I shape? Okay, because you find out that when you calculate the molar mass, they are the same. Okay, they are actually different in terms of molecular shape. Jadi cerita dah pasal molecular shape. Okay, so nak cerita yang mana? Heptane. Dia tanya why is it heptane to saya kan? Okay, jom kita cerita pasal heptane. So heptane. Apa shape dia? It's a straight chain. Tak suka perkataan straight chain, boleh guna perkataan apa? Ha? Long. Long chain ke long? Long okay, boleh lah. Okay, tak suka guna straight chain, tak suka guna long, guna apa? Cylindrical shape. Okay. Cylindrical. Panjang. Lumayan lah, cylindrical. Okay. Heptane. You guna apa tadi? Anak guna apa? Straight chain. Okay, gunalah straight chain. Mana-mana lah bahasa yang mudah untuk you all. Yang sewaktu dengannya. Straight chain. Okay, so kalau straight chain ni apa? So what happen in straight chain? Does more contact area. Contact area tu apa ni? For the attraction or for the LDF. Because LDF is about attraction, betul? Betul? Okay, so lagi banyak, lagi besar the surface area, the stronger the attraction. Got it? Okay, so macam ni nak buat. Buat ayat. Does more contact area resulting in stronger LDF. So bila stronger LDF, macam ni. Therefore, hence, lagi apa? Boleh. Higher boiling point. Stronger LDF, higher boiling point. Stronger LDF, higher boiling point lah. What happened actually? Okay, more energy needed to break the attractive forces. Okay, ataupun to overcome the attraction. Betul lah, tambah lagi. Tengok markah lah. Kalau markah sampai 5, tambah lagi. Nanti lagi.
Oh, 3 lah.
Okay? Oh, 3. Madam Didi kata 3.
Sampai pun 3. 3 ni tadi.
Okay, boleh? Boleh. Okay, next. Proceed. Okay, table 4 shows the boiling point of these 3 compounds or 3 liquid. Arrange this liquid in order of decreasing surface tension, volatility. Okay, and then kita tambah lagi vapor pressure. Boleh? Vapor pressure. Okay, and then apa lagi kita ada? Viscosity. Okay, apa? Volatility reduction. Dan dia volatility. Okay, jom arrange. Okay, cara arrange. I will arrange this. Okay, no doubt that all these properties of liquid actually affected by the IMF. Okay, so the first thing that you have to do is to identify among all the 3 compounds, siapa lagi kuat, siapa paling kuat the IMF. Okay. So from the boiling point, the IMF in terms of the strength of IMF. Okay, macam nak susun macam mana? Dia nak decreasing. Kita dah tengok cerita increasing IMF lah. Okay, increasing IMF siapa dulu? Okay, E followed by Dadu followed by Raja. Okay, so this is increasing order. Increasing order means you can use this symbol. Tapi kalau tak tahu guna symbol ni, jangan guna ya. Guna common je. Okay, if you are confused in using this symbol, which is larger than or smaller than, don't use this symbol. Guna je lah common to be at the same side. Okay, kita akan baca dia as what the question one. Okay, so once we know the strength of IMF, then you can start to arrange the surface tension, volatility, vapor pressure, and also viscosity. Okay, what will be the arrangement?
Surface tension.
Surface tension. Apa itu surface tension? Yang you faham? Kenapa dia on? understand from surface tension? What is the definition of surface tension and resistance? Definition. Molecule. Okay, so they put inside to surface tension. Because the simplest method cannot. Okay, daya yang menarik molekul ke bawah yang menyebabkan ni ada daya di permukaan. Adanya tension di ketegangan di permukaan air. Okay, so kalau kita kata the intermolecular forces stronger, so dia kalikan dia lagi kuat ke bawah, so tension dia lagi tinggi. So nak kena jawab bahasa Melayu pun ini exam. Okay, so how we do the arrangement? Okay, the arrangement will be G, then B, and then E. Okay, how about water type volatility? E, E, G. Okay, vapor pressure. Start from E, E, G. Betul? Okay, how about viscosity? G, D, E. Okay, dah. Bukan A semua. InsyaAllah. Okay, Bena nak tanya satu. Asal go back from water. Dia bilang sikit lagi. Water. H2O. Can you identify the cut-off hybridization for the central atom? SP3. SP3. The rest of this is 2. Are you agree with that? Above? Yes. Okay. Dah. Boleh balik dah. Pandai. Okay. If let's say, satu lagi.
Takut soalan.
Between potassium and rubidium. Potassium and rubidium. Which one will have higher melting point? Or boiling point? Why not? Rubidium. Why? Why is it? More mass. So they don't okay. Itu kau satu more mass? Kenapa? Because of the size? Is it because of the size? Okay, now sini pasal apa? If let's say you want to explain, how is it? We're going to explain. Between potassium and rubidium. Selalu sangat salah ni. Potassium. K and RB. Potassium and rubidium. Sekarang. Which one higher melting point or boiling point? Rubidium. The reason? Molar mass. Dapat mangkas rubidium. Itu molar mass. Sorry, kosong. What is your higher melting point? Why? Okay. So, kalau dia ada soalan macam ni, okay, nak tackle soalan-soalan yang begini, you kena tahu dulu you deal dengan apa. Okay? This potassium and rubidium is actually metal. Okay. So, it has nothing to do with IMF. Dia tak ada kena dengan IMF. Okay, bila dia ada metal, so you kena tengok the strength of metallic bond. The stronger the metallic bond, the higher the melting point or the boiling point. Okay, so between these two, siapa lagi kuat? Siapa lagi kuat? Okay, strength of metallic bond. Apa ya? Siapa tentukan strength of metallic bond? Okay. Electrons. Okay, remember how many electrons? If they are the same, then you are looking at the size of atom. Okay, how is the relationship size atom dengan the strength of metallic bond? The greater the size or the larger the size, what happens to metallic bond? The stronger the weaker. The weaker. So, satu lagi tinggi. Sebab dia tinggi. Okay. Okay. Jangan semua soalan sudah berada dalam tingkuan wanita semua yang sapu IMF. Semua cerita pasal IMF. Ya, this is your answer sebenarnya. Based on my experience. Inilah cerita, tolong ya. Okay, so apa you deal with? Okay? Okay, so I think that's all. So thank you very much. Okay, because still here, still mereka mata masih buka. Okay? So wish you all the best for your exam ya. Okay, so thank you very much. And thank you very much that there was fire and the Satya for tonight. Okay, everybody happy? So I think your understanding getting more clearer. So, on behalf of the chemistry department, so we bring the best for you. Okay, so we hope that everybody managed to answer your EOSE final exam on 27. Okay, so there is no other tips that we can share. First adalah what you need to do is please do a revision. Go through the tutorials, go through all the figures that you have seen before, check where you can mistake, now mana yang you tak faham, please do, and if let's say that you still tak faham, and go and see your lecturer. Okay, go to see your lecturer. We are very happy to help you. Okay, do not feel that apa kalau susah tak boleh nak jawab, that is the end of the day. No. Okay, so the QR code will be given to you. Please scan the QR code. And then last but not least, can we all together? Okay, so can we all together sama-sama to take a picture? Boleh?
Aku nak beli kan?
Nampaknya sambil kan? Gila aku, gila. Panggil ni. Jom. Mana lagi tim?
Ada je tapi tak ramai. Mana tadi yang
Ni, pengacara majlis. Saya depan. Later, baca kutu dengan brother tu.
alright.
Sebab tak bawa tripod. Okay, mari Pak. Apa nak gambar apa? Apa nak put together? I don't know him respect. Brothers and sisters, macam bangun bangun nak balik dah. Cepat. Awan. Bangun, tunjuk kat tengah. Okey. Ada cepat dapat kat sini. Okay, first kita ambil gambar dulu ni. Masing-masing kena senyum ni. 4, 1, 2, 3 senyum.
1, 2, 3. 1, 2, 3.
Okay, kita video ni. Okay, kita buat video. Okay, so untuk video yang sama chemistry, you want to apa? In after 37. Jangan dulu lagi. Okay, so Madam Sanggup Chemistry, you want to apa? Right, so 1, 2, 3, chemistry. Thank you very much. Thank you for coming tonight.
Video ni.